I'm going to go over some exponent rules that you'll be using to solve SAT math problems. Without understanding these rules, you'll not be able to tackle these problems with speed and accuracy. Okay, here they are. I don't want you to memorize these. Instead, I want you to understand why we have these properties. Well, here, the values of a, b, m, and n can be any numbers. That's right, any numbers, even complex numbers. Well, in SAT, of course, we're not dealing with complex numbers. But I just want to tell you that these exponent properties are not just for integers. Of course, the denominator cannot be zero in any circumstances in math, so I indicated them here within parentheses. Even though these properties work for any numbers, they're easily explained with integers. So we're going to stick with integers to explain these properties. So for the first property, let's simplify a to the 5 times a to the 3, for example. Since a to the 5 means you multiply a 5 times, and a to the 3 means you multiply a 3 times, you can express them this way. We see that the result is nothing but a multiplied a times, which can be obtained by adding those exponents 5 and 3. You can use the same reasoning to explain the other 4 properties like these. And please pause the video to agree with me on these completely. Believe it or not, this reasoning will really help you remember these exponent properties. Okay, before we move to the next page, I'd like to mention something on the second property here. A to the m over a to the n can be rewritten as a to the m times 1 over a to the n. Now, if you define this 1 over a to the n as a to the negative n, we can just use the first property of exponent to simplify like this. And we have a to the m minus n power. So we have another identity to remember here. 1 over a to the n power is equal to a to the negative n power. If you are preparing for the PSAT math, you can skip this part of the video. PSAT doesn't seem to give you any problems relating to this fractional exponent. Okay, so for SAT math students, suppose we have a to the m power is equal to b to the n. Mathematically, there is no restriction on the values of m and n, but this property is very useful when we have positive integers for m and n. If a to the m is equal to b to the n, a could be written as b to the n over m power, and b could be written as a to the m over n power. To understand this, let's take a look at the first one. We start with a to the m equals b to the n. Let's take 1 over m power on both sides of the equation. Then using the exponent property we just learned, the left-hand side becomes a and the right side becomes b to the n over m, which is what we have there. For the second one, we can take 1 over n power on both sides of the equation a to the m equals b to the n, and we get b equals a to the m over n power. Now let me show you another important convention you must know about fractional exponent. Here is the original equation, a to the m equals b to the n. Now if you take the m power on the mth root of b to the n, you get b to the n back. Well, these two quantities are all equal to b to the n, so they're equal to each other. Now let's take a look at these quantities inside the power of m. They must be equal to each other. So we have a is equal to mth root of b to the n. Now look at these two quantities. Since they're all equal to a, they must be equal to each other. This is a very, very important identity you must remember. Therefore, inside the box, this b to the n over m is equal to mth root of b to the n. And this a to the m over n power is equal to nth root of a to the m power. Well, when we see square root of a, for example, this 2 is omitted. So by convention, if you have square root of a, it's same as this. And since a is same as 8 to the 1 power, by what we learned from the identity, it is nothing but 8 to the 1/2 power. All right, now you're ready to tackle problems. Let's begin.